Hi all, back here today to see if we can do a comparison of a double lead carbon cell connected in parallel versus the lead and carbon and zinc and carbon cell. So the tub to the left here has the two carbon lead cells connected in parallel. They've been around now for 4 days, and that's probably been about 6 days. That's the lead carbon and zinc carbon cell. I've charged and discharged this one a couple of times. It seems to have way more power output, but for less time, but it's delivering up to 100 milliamps for a couple of minutes, seconds, not minutes. So that's what it looks like. It's the same setup as the others, but it's a lead and a carbon with manganese dioxide and gel soaked in Epsom salts. So the voltage looks pretty low. Oh, we're on the 200 range. Alright, so the voltage for the two lead cells in parallel is not very great, so 0.3929, and short circuit on milliamps, we're on the 200 range. Short circuiting now. Is everything hooked up? Oh, yeah. Forgot a lead. Okay. Alright, short circuiting now. Alright, it's got about like 12, 14 it had. Alright, oops. Oh yeah, that's good, that can stay in there. Alright, so we'll give it a charge on 4 volts. This is the double lead cell in parallel. We're set on 4 volts. Charging. Set the timer. Oops. Change the amps. Strange thing I noticed on charge up on this, it takes, well, when I first connected it, the milliamps was up near 700 milliamps, and it was just sitting there, it sat there. Now it's after about 5 charges and discharges, starts to decrease in the milliamps. We're about 35 seconds into a charge. I've given it a 10-minute charge on 4 volts, and wow, you wait till you see that, but it only has like about a 7-minute lifespan, but does it deliver? Alright, we're coming up, we're about a minute now. Disconnecting. Voltages will drop probably to about 1. I'm thinking it's got different characteristics now, this cell, to whatever it had when I first started. It's been idle, both cells have been idle for 2 days without a charge or anything. That's why that lead cell just then had hardly any voltage or amp. Alright, we'll hook up. Oh, I'll reset the timer. So I think on the zinc and lead cell we had 3-minute runtime on a 1-minute charge. Alright, we're dropping. I thought we were going to hold at 1.8. Okay, alright, so we'll hook up the load and wait and see how long it takes to discharge. We're like 50 milliamps. I should have changed it over. Forgot to press the timer until then. The motor is spinning. You can actually hear it. 30 milliamps. sort of wreck that. We're not going to see it will be 0 milliamps. Well, I might be able to be quick enough to change it over, and that would be the time I lost in pressing the start. Back. Yeah. Oh, what happened? I reckon one of my leads is, I reckon that lead there is ready to fall out. Alright, we're at 54 seconds. We're holding. Actually, it's not looking too bad. The first time I did that, it wasn't looking that good. But now it is. Funny thing is, when you give it a 10-minute charge, see that weird orange looking stuff? Well, it produces a bit of that, and it dissolves, but that some of it doesn't dissolve. It must have traces of lead or something. The 4 volts could be tearing the lead plate apart. You can see the yellowing colour. That one has less, but it does have it at the bottom. We're still doing 20 milliamps. The milliamps is higher on the lead cells, all the way until the end. And then that's where the differences in the two cells begin to be able to be noticed. Like this one will hold 11 milliamps constantly for a while, and this one will keep dropping. It'll probably drop to 0. I've taken it to about 5 milliamps with the load connected. So other than that, this double lead parallel cell actually is much better. I'm quite surprised. I hit the 100 milliamp club. Is there a club? There should be. There we got 2:45 seconds. We could get more than 3 minutes now. It's actually seems to be improving. Maybe we'll see. Oh yeah, we're coming up to 3 minutes, and we're still at 0.22. Normally runs down to 0.1, and around about 11 to 10 milliamps. Yeah, we've actually hit 3 minutes. So now it's actually producing way better. So the difference in the 2 different types of cells in the one solution is pretty small. Probably wouldn't amount to much really. On the micro scale we sort of seen here, looked impressive, but when you hook up the 2 lead cells, not so. Not saying some of the other metals might work much better together in a combination. Still might be worth looking at. Every milliamp pinched is a good thing. Yeah, we're getting 4 minutes. We're at 0.17. Still got 12 milliamps. Yeah, definitely. This is a bit longer. It only got like 20 seconds on the first time I tested that cell. Alright, we're running out, we're out. So we got to 4 minutes and 50 seconds. That's not too bad. And take note, the milliamps keeps dropping, where the zinc and lead cell, it would be holding still for a much longer period. I think it did go down, but not as fast. Yeah, see, we're dropping. Alright, so disconnect, turn off the stop, reset. Alright, I'll give it a charge for 10 minutes. Oh, I'll change that over. Okay, starting to charge for 10 minutes. Setting the timer. Timer's on. Alright, we got 410 milliamps. And I'll get back at the 10-minute mark. Okay, we've just got past the 10-minute mark. We're still at 340 milliamps and 4.36 volts. I'll just disconnect the load. Oh, hang on, I'll show you the cell. See the brownish yellowy looking stuff growing? I have no idea what that would be. Anyway, looks like one of the most disgusting cells ever. Alright, so we'll disconnect the power supply. I'll swap over the meter to the milliamp range. Alright. So it's sort of slowing down at 2.3 volts. Not too bad. Alright, you check this out, I'll hook up the load. Oh, first I'll reset the timer. Okay, timer's reset, ready to go. Alright, I'll hook up the load. Check out that milliamps. And hear that motor buzz. But it's not all rosy. I put a 10-minute charge and left it overnight, and I think I got like a 3-minute run time on that, but short burst of think about 90 milliamps and then it dropped right down. It's performs much better directly after a charge, so again it suffers from self-discharge, or it doesn't quite work, but still impressive. We're still at 50 milliamps, 40 seconds. It's on the 200 range. I think we still only get like 7 minutes, I reckon, of run time. One minute 13. Still delivering 45 milliamps. So with the composite cell, it's a subtle difference. There is a difference. The voltage is actually higher on the composite cell than it is actually on the dual lead cell. So that's got to be a sort of a bonus. We're coming up to the 2-minute range. And we're still holding 39 milliamps. It does perform pretty well. The voltage seems to hold a bit higher, so going by that, we could get a 10-minute charge maybe this time. It'll be interesting because the last time I tried a 10-minute charge, it was around about 7 minutes took to discharge down to motor stoppage, and about 0.1 the bounce back's not very high on the dual lead carbon cell. Perhaps the Epsom salt solution could be too strong. That's where the electron leakage is coming, maybe. It's 200 mils to 10 spoons. One of these wider, large white type spoons. Here's a little one what comes at KFC. So maybe that's a tablespoon perhaps. I'm not sure. We've got to 326. Definitely the voltage drop is slower. Alright, I'll get back when it's sort of just before the blade starts slowing too much. Okay, I'm back. It didn't hit the 7-minute mark. And we're probably ready to run out. You can start to see the blade slow right down. I think round about 0.1 the blade should stop. $7.43 we're at. Here we are. Yeah, we're going. Blade stoppage. Alright, we're at 8 minutes. So we got an extra minute after being left for a couple of days and a few charges and discharges. And we're slowly dropping in milliamps. That seems to have slowed down a great lot. It used to drop a bit quicker than that. So I'll disconnect the load, we'll watch it bounce back to whatever it's going to go to. I think it was at, when we first started, was 0.4, so we've gone up a little bit, so it still has a bit of power left in it. That looks like it's about it, it's just fluctuating then. I'll give it a short circuit, see what we got left. Short circuiting now. We still had 41 milliamps on a short circuit. Ah, there you go. Dual lead carbon cell in Epsom salt solution, and the zinc and lead cell. I don't think we can compare them actually. They're two different types of cells. Well, this one definitely has way more milliamps, so that would be the winner, clearly. Alright, well, thanks for watching. I'll catch you next time.